What if someone told you that life on Earth was the product of blind, undirected processes? And the notion of purposeful design in nature was destroyed by Darwin's theory in the 19th century? What if explanations for the genius of the animal kingdom were limited to natural selection and errors in the DNA code? And if schools taught that the origin of eagles, whales, and monarch butterflies was once determined by the luck of the draw in a genetic lottery? What if science insisted that the hypothesis of a creator is nothing more than a bedtime story, and reality itself is merely random interactions of matter and energy? How would you respond? Could you disagree with confidence and conviction? Now you can. The Design of Life Collection. As human beings, we are instinctively drawn toward the grandeur of the natural world, to spectacular displays that inspire us with their magnitude and power. During moments like these, we are understandably filled with a genuine sense of awe. Yet nature's most stunning revelations aren't always defined by sheer force or physical scale. For often, in secluded corners of our planet, many of Earth's greatest wonders take center stage. Wonders of rare beauty and complexity, creativity and design. Wonders born on the gossamer wings of an insect weighing less than an ounce.
As you watch a butterfly, to describe what you're looking at, you can't really put it into words. And I said to myself, I want to be part of that. That is the coolest thing. That's biology, it's also magic.
When you hold a living butterfly in your hand for the first time, maybe you've netted it or you've picked it off a flower or something, here's this incredibly beautiful organism, intricately shaped with its feet and antennae and all these things moving at once.
Every one of these 20,000 species have different color patterns, and every one of them has different shaped wings. The diversity is just so magnificent. If I was the greatest artist in the world, there was no way I could come up with all of these patterns. I mean, it would be just absolutely impossible.
If you open the work of a lepidopterist, someone who studies butterflies, somewhere in that writing, you're going to find the language of astonishment. The fact that it goes through a caterpillar stage and then becomes this mysterious chrysalis, out of which this flying creature emerges, has captured the imagination of people since antiquity.
Throughout history, butterflies have touched the human mind and soul on levels both scientific and philosophical. 3,500 years ago, Egyptian artists studied their anatomies and then rendered them as icons of beauty and perfection of form. In Aztec and Mayan folklore, the insect symbolized life and death. And to the ancient Greeks, Psyche, the word for butterfly, literally meant the soul. Today, terms like magical and miraculous are often used to describe their mysterious life cycles. For almost every butterfly, it is a cycle that begins, often hidden from the eyes of the world. Depending upon its species, a female butterfly can lay hundreds of eggs during her brief lifetime. Each initiates an extraordinary process of growth and transformation.
The eggs are remarkable in themselves. They have species-specific architectures, some of which are just astonishing. For instance, if you look at a monarch egg, it has a beautiful symmetrical structure. It looks like a little miniature dome or cathedral.
Ranging in size from a pinhead to the width of a child's fingernail, each egg is attached to a plant by an adhesive fluid secreted by the butterfly. They are lined with a coating of wax that helps keep them moist and viable. Each egg is deposited on a specific species of plant called a host. These host plants are the only source of food a butterfly's offspring will eat. So accurate identification of their leaves and branches is crucial, and the females are well equipped for the task.
The perception that they have of the odor of those plants is just overwhelming. So they can find those plants for miles, and then once it gets near its host plant, it can tell that the odor is getting stronger and stronger. Then it begins to focus on leaf shape. Instinctively, it knows what leaf shape its host plant has. And it begins to taste. And it tastes with its feet, with its forelegs. They drum the leaves, they scratch the leaves, and then they use their proboscis to taste the scratch. They also smell with their antennae. So they've got the legs, they've got their proboscis, they've got their antennae. They have all these mechanisms to make sure that it's the right plant. If it's the wrong plant, their caterpillars are going to die. Butterflies just don't make mistakes. I mean, it's just amazing. It's one of the greatest wonders of nature to watch how this female can do all of this from such great distances.
In many species, the eggs hatch within a week. Then the newly emerged caterpillar, or larva, wastes no time embarking on the second stage of its journey to adulthood.
We call them eating machines because that's their only purpose in life, is to just eat and grow, eat and grow.
A really hungry, busy caterpillar, you can actually hear it eating. It sort of reminds you of corn on the cob, because it bites along and then it bites along some more.
It's just munch, 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 munch. Slice and chew, slice and chew, to build up the raw materials for the next stage of life.
A caterpillar could gain in weight so fast that it would be eating its own weight in leafy material every day.
Equipped with powerful jaws and a digestive tract that extends the length of its body, this stomach with legs can multiply its birth weight more than 3,000 times in less than 2 weeks.
To show you how remarkable this weight gain is, imagine you had an 8-pound human baby and he multiplied his weight 3,000 times as he was growing. That would be a 24,000-pound child. That's a big kid.
A caterpillar's growth is punctuated by violent surges of transition called molts.
Imagine the outer skin of a caterpillar as being sort of like a wetsuit. It's got a little bit of stretch to it, but limited. It's waterproof, so they don't dehydrate. Now, as the caterpillar grows, it fills out that wetsuit, and eventually it reaches a point where it can't grow anymore, and it has to make a new, larger version on the inside.
A molt begins when a caterpillar spins and then grasps a silk pad, anchors its body securely with small barbs on its legs, and splits its skin near the capsule covering its head.
There are sensors in the cuticle, in the skin of the caterpillar, that are strain detectors. They detect the amount of pressure or strain being put on the skin. And when that is too great, they send a signal to the brain of the caterpillar, which then releases a hormone that causes molting.
A caterpillar will undergo 4 or 5 molts. Its rapidly growing body is composed of 2 distinct cell populations: the larval cells that form all of its organs and enable it to function, and the imaginal cells that ensure its future as a butterfly.
In the later instars of the caterpillar, one can begin to see what are called imaginal discs. Now, these are the precursor cell populations for what will become wings and legs or sensory structures in the adult.
Most of these imaginal cell clusters develop in pairs and are positioned throughout the caterpillar's body in locations that correspond to the organs they will eventually help form in the adult.
Imaginal discs are precursors that are there and waiting. They're set aside to make adult structures. And at a certain point in development, those cells are triggered to start to grow.